Today we'll discuss LeetCode contest problem, rotating the box. So let's go over the problem statement. So here it tells ki we have a matrix and it has three kind of objects in it, three kind of cell types. Hash denoted by stone, stationary obstacle denoted by asterisk, and an empty as dot. Okay, now we rotate the box 90-degree clockwise, and due to which some stones they start falling due to gravity if there is no obstacle or there is no other stones in between. So as you can see in examples, and at the end we have to return the resultant matrix. Okay, so this was a matrix, like I just rotated it 90-degree clockwise. So this stone was already at the bottom, so this maps to here, but this moves to this cell, which is shown over here because due to gravity, as there was no obstacle or other stones. Similarly, if we see example over here, uh, these two are empty, so it will remain like empty. These two are obstacles, so it will remain like that. This becomes this becomes this, because like this had nowhere to move down, and this stone it moved down to this cell. So I think we got the problem statement. So let's quickly jump to the solution. Okay, so as you can notice key, all the stones will remain in the same row. So like let's say this stone it moved from here to here, like it will remain in the same row. I'm talking about this matrix. Okay, it will remain here. Similarly, this stone it becomes this, but it will remain in the same row. Okay, the same row I'm talking about the first matrix. Okay, so what we need to do, we need to process the input matrix row wise, and we just need to make sure key like only the columns will get updated, row will remain the same. Okay, so once we update uh, all the stones to the updated j, keeping the row same, then we just need to create a resultant matrix. Okay, so let me just quickly go to the code and see how we can implement it. So here I took n as the number of rows and m is the number of columns, uh, because here already m and n were greater than 1. So this will pass the null check exception, and this was my answer matrix, final 90-degree rotated matrix. So now I will process my input initial matrix row wise. Okay, so I'm iterating over the row, and in each row I'm keeping two things. When was the last obstacle found, and number of stones I found since the last obstacle. So this last row basically is the column number of the last obstacle found in that row, and this is the number of stones we encountered from the last obstacle found. Okay, so initially this will be the last like column m, and number of stones found will be 0, and then we'll move from like right to the left, because we know key it's better to update this, like we need to update from the right side, right? This will come here, then this will come here, then accordingly it will adjust, right? So that's why I'm iterating the loop from right to left. So if I see my box type is an obstacle, so then I know key, okay, last obstacle I got a new obstacle, so I updated my last obstacle index, and here the number of stones found become 0, because now like we have an obstacle, so uh, like number of stones found in the last obstacle becomes 0. Okay, now if it was some stone, then either it will go down or it will stay as it is. Okay, so the new j, what will become, new j will become last obstacle minus the number of stones minus 1. Okay, because it won't go down like right of the last obstacle, and we need to make sure ki what were the number of stones found since we encountered the last obstacle, because it won't replace other stone, it will like be above that only. And this is -1 to get its new updated index. Okay, and then whatever was its source column will update it to empty matrix, and whatever new column will add that new stone with an asterisk, and will update the number of stones with plus plus, so that we use this information for its on the left side stones. Okay, now we updated the original like metrics, like we slided everything down as far as right as possible. Okay, but we need to output this matrix. Okay, so what I did, I just in the input matrix, I only just traversed in some, I traversed column wise. So what I did, so this was my first column, right? I just, so this will become my this thing. Let me take a better example. Let's say ki, all right, all right. So my point is ki, let's say ki, uh, I slided everything down as right as possible. Now, whatever was in my first column, this will become my first row over here, and whatever will be in my second column will become second row over here. Okay, so that way I'm doing. So I'm iterating column wise, and then I'm iterating like row wise, and then in a vector I'm pushing back the box element, because this I know already has those gravity changes and movement information updated, and then I'm just pushing back that column information back to the row of ants. So this I'm doing over here, and in the end I'm returning just ants, and I think that's it. So this will ensure my that I'm getting the updated metrics, which is counterclockwise rotated by 90 degree. Okay, you can apply some, I think, yeah, this is one of the way. There might be other ways out, but I followed this, and I'll just go ahead and submit. So yeah, I think it passed. So that's all for today. I hope you liked this video, and please like and subscribe so that I get more motivation to make such videos. And stay safe and have a nice day. Thank you.